All right, what is up? Good morning. Let's rearrange a few things here. All right, there we are. Welcome. Top. Welcome. Thanks for watching. Anyone who is hanging out here in the live stream or watches the video after the fact. If you are new and don't know, my name is Tim. I go by Foamy Guy on GitHub and Discord, and I stream around this time each week, 10 a.m. on Tuesdays here on the Adafruit channel, working on stuff related to CircuitPython. If you don't know what CircuitPython is, you can learn more about it at the main website for it here, CircuitPython.org. This is basically a version of Python that runs on tiny computers called microcontrollers. You can plug them in. Typically, I should say, the way this works is you'll plug it into your computer with a USB cable. It shows up like a thumb drive. You can edit a Python code file on that thumb drive. When you save it, it will execute the Python code for you, and your code can interface with whatever other peripherals you hook up to that microcontroller. Let's see here. Okay. Some of them are very general, like these Raspberry Pi Picos just have a boatload of I/O pins that can effectively do almost anything and hook up to almost any sort of device. Others are more purpose-built, like the Sparkle Motion, Sparkle Motion line of devices, which are sort of LED-centric WLED X lights, sort of targeted devices, although they do also support CircuitPython in this case, and they have hardware that's more suited to a specific use case. In this case, you can hook up NeoPixels and create cool animations and other effects with them. And they also have a Wi-Fi chip so they can connect to the network, and you can control them through your phone or your other computers and stuff like that. So this is the high-level version of what CircuitPython is. As always, you can learn more at CircuitPython.org. If you are interested, I would encourage you to come join us in the Discord, which is shown below. There's CircuitPython development channel and a help with CircuitPython channel. If you are at all interested, there's always sort of interesting discussions going on in there that are around CircuitPython. I will also mention, as always, thanks to Adafruit. Adafruit is a hardware and software company based out of New York. As you all likely know, the folks watching the stream here, Adafruit pays a team of folks to develop CircuitPython. There's a team of folks who work on it full-time. There are some folks who work on it part-time. Adafruit also employs people, pays people to work on other open source projects as well outside the CircuitPython world. So if you would like to help support them, CircuitPython, and all of the rest of the open source software that they fund, one of the easiest ways to do it is by purchasing hardware from them at their website, which you can do, Adafruit.com. They have the Sparkle Motions, like I pulled up a minute ago, which was a bit of a premonition, so to speak, a little glimpse into what's to come. They also have all sorts of other microcontrollers and doodads to hook up to your microcontroller to make fun stuff with. What is up, Liz? Good morning. Okay. So I will pull back up the camera. I am looking into today I2S microphone input. So on, in fact, we'll just go ahead and pull up the Sparkle Motion page. On the Sparkle Motion, one of the things that this device has is a little I2S microphone. I think that's it, although I'm not actually sure. It's labeled, I think. Maybe it comes through the back. I don't know exactly how it works or which component it is, but there's a microphone there. Usually they'll have the little hole. Yeah, I don't know how that one works. Maybe it's on the board side. But in any case, there's an I2S microphone, and in CircuitPython, we did not previously have the ability to use it. Although I will say, also, let's pull this up. Shout out, Hug Report goes to Relic SE Cooper. Actually had a PR for this a while ago, which I did not realize when I started working on this, which is going to be nice. I think I'm going to try to take the other implementations from this. So There was some work a while ago, into 2024, to get I2S input going. And I have kind of not quite picked that up because, again, I didn't actually realize this was here, but picked up the effort to get those microphones working. And I have a instance working here. I'll go back to the camera where it is working successfully. I have this hooked up right now to just like a, what do you call it, audio reactive. So if I stop talking for a second and tap, it can pick up taps really good, obviously, because it's sitting on the desk. And it will react to me talking as well here. Also, and I was trying to figure out what music I could use during the stream and not get in trouble, and I landed on, oh, close to the camera. I landed on the Adafruit jingles, which I found here on SoundCloud, which is nice. I don't think that comes through. I'll give you the quiet version. Okay. So this is a relatively basic example, but I think it's perfect for this device because it can do this with Arduino code already. It can do this with WLED, but we did not have the ability to do it in CircuitPython quite yet. But I would not like to make it so that we do. And that's what we're working on. The basics, as you can see, are pretty much working on Espressif. I have also implemented, and when I say I mean with lots of help from Claude, implemented the Raspberry Pi port as well. But I have not tested the Raspberry Pi port yet. This is actually the only thing I have that I know of that has a I2S mic on it. So it was a challenge to figure out how to test other ports. It was also a bit of a challenge to figure out how to test something other than the sort of live thing that this is doing, right? This is recording sound, but it's only recording like a small sample and then it's acting upon it immediately and throwing it away. I did also want to test to make sure it could like save an audio file, for instance. But it turns out I kind of need an SD card for that. I did get one hooked up. It was probably wins the award for the most awkward thing I've ever wired up. SD card featherwing to this Sparkle motion, but I was able to record like a 30-second wave and save it on there, which is cool as well. But this, I think, shows off what it's doing much better. And this code, I'll show you the code here. It actually does do FFT. We'll go back to big on this one. So this is using Microlab to read and then use fast Fourier transform to kind of filter out different bands of frequencies. And then, of course, in this case, it's got them wired up to 3 different NeoPixel strips. And it's kind of bouncing the strips along based on the different values that it finds in each of those bands. And this is really cool. I was actually encouraged, pleasantly surprised to see that we could do all of this in CircuitPython here and have it actually stay nice and snappy and kind of real time with the audio. So I'm very pleased actually with how it's able to keep up. Cool stuff. But the next thing to do is test what this instance of Claude here has just done, which is refactor it out of Audio Bus IO over into its own new module, Audio I2SIn, based on some feedback I got from Scott yesterday during the meeting. So this should be mostly moved over. We just need to bring in the code over to here and make the build for it. So how do I want to do that? I think one thing we need, I think I'm going to make a new branch first of all, because I put the name of the module in the branch, Audio Bus IO I2SIn. And since we're moving to a different module, it would make sense not to have it in the name. Let's update this. Actually, let's just check out this. Can we do that? Okay. I also accidentally named the folder I'm working in I2S out, but it's fine. Still works. Okay, so we got that. I would like to make a new branch. And then I would like to see all the files that were changed in this one compared to main, which we could just compare to the new branch we just created since it's also made from main. And we will basically need to copy these same files. I don't think we have to worry about this. This will get generated. This we will want, I didn't mean to double click it. This has the pins for the sparkle motion. Can I pull those in? Vert. Create patch? Cherry pick. Get from revision? It sounds like it would pull it in to this branch that we're on, right? Do this now? Push rather. Okay. Yeah. There's also a bunch of Raspberry Pi stuff here already, which we are not going to want. I'm not sure why that stuff is actually here right now. I think maybe this never got committed. So before I do that, I'm actually going to just commit this locally so that it's saved somewhere and so that it's not just hanging out in uncommitted changes. Then we can compare this. And yeah, that totally does exactly what I want, which is pull in that thing from this change. And then basically the rest of this we won't want because instead we have new folders for all of these things. We'll need to grab these files as well. Okay, so we want to get shared bindings, the new one. We want to get the tests. We want to get these two files. So we'll start there. This is the code that this Claude is editing, linked up onto this Raspberry Pi that I have over here. So two files we wanted were pi, CircuitPy defines, and mp config.mk. And then shared bindings. I made the new one here, audio. In fact, we could just do the whole folder. That's easiest. Tests. Backwards, I think. Huh. It deleted the tests. Or it left them here? Seems odd. Oh. Okay. It updated them to import them from the new place, but it left them in the old folder. Interesting. I think what we'll do is make a new folder. Audio I2SIn. We may not need all of these tests in the core repo, but I did use them while validating that it works, and I will on the Raspberry Pi port once I get another microphone breakout that I can hook up. Okay, we got these two files, we got shared bindings, we got the tests. So the other stuff we would need is the port implementations, which are going to be in ports. This needs to go back right ways up. Ports. So right now the two that are in this branch are Espressif and Raspberry Pi, but I haven't tested Raspberry Pi and I don't have the hardware yet to be able to. So we're gonna go to Espressif first, Common HAL, and then it would have been in here before, and now it's here. We're gonna take that over to this one. It would probably be nice to be able to just build from this. One of the things I think I'm going to do is move off of a Raspberry Pi. So like this is running in the Raspberry Pi and these files are on the Raspberry Pi and I'm copying them over to my local machine here to be able to make the build, because I don't want to do the build on the Pi because it would be slow. And also because doing the full build and the submodule updates and everything ends up downloading a moderate amount of stuff, not that much by today's standards, but kind of a lot for a Pi that has only a 32 gig SD card in it. I think I'm going to end up upgrading to a different, it's an old computer that I have that's got a bigger hard drive and runs a bit faster than a Pi. Be able to just paste this in here. Okay. Theoretically, that should be all we need to test the Espressif build. So we need to do what? We need to export the thing, right? IDF thing, ESP, IDF, export. And then we need to remember the exact build name. This one's actually pretty easy. The mini one threw me off, though. I think it's got no Adafruit or something was different about the mini one. I don't remember what it was. I didn't end up needing to build the mini one anyway, though. And not. Do clean for actually clean with the correct syntax. And then to flash this one, we actually it doesn't have UF2 bootloader. To flash it, we need to use a web serial thing. I don't know the URL to off the top of my head, but it's linked on the Sparkle Motion. SP web flasher tool. I should bookmark this. I don't know if I'll remember that it's bookmarked. That's my problem with bookmarks, is I like occasionally this would be a good thing to have, but then I don't look in there, or I don't remember that that specific thing is in there. Okay, let's see. Still building. Download a backup of, yeah, I have a backup of all the code files as well from the Sparkle Motion. It shouldn't, I don't think, overwrite them when we do this, but, well, maybe if we click erase. We could try it without erase. But in any case, I have them all backed up. Okay. Did actually build successfully. First try, so good job refactoring, Claude. So to flash it, what we need to do is go back to this. The device is already connected over USB, so this cable is plugged into the computer that we're on here. So we can go here, connect this. Actually, do I have TO running somewhere? No. Oh, but we probably don't. You know what we need to do probably is disconnect on this. Probably. Okay, there we go. Use a file. All right, conveniently this is already here, although I don't trust it, so I'm gonna go back out and in because I deleted that old one. I mean, it should be fine, but I can choose the bin file. And I'll try we'll see, I'll try just program. See if it works with just program. I think the guide says erase and then program, which is usually what I do. And I'll leave this tab up as well. I think I found if you tab to a different thing, it can slow it down sometimes. I don't know if that's just anecdote, what it felt like or not, but. Should hopefully be the same API and everything as well. So we should be able to just take the code that's there, change the import, and hopefully it just works again. Anything. Some of them have a little flashy one. Sent. Run it, reboot is which one? Oh, there's CircuitPython blinks. We can disconnect this. It is, well, yeah, obviously it's not working now because the import would be wrong. Probably just got the import error. Because it would have tried to import audio bus IO. And failed. But we just go here. You just import the whole thing from audio I2SIn. Import I2SIn. Don't use Control W. Don't use Control W. PyCharm and associated IDEs have spoiled me. They have this Control W key hotcut that will shortcut rather that will sort of like select outwards from the cursor. It's very useful, and it kind of like where it will jump to is based on the code syntax. It's, oh. No module. So that's definitely not working. I think we should check some of these things. So I did this as what in it? Oh, I bet. So this is like I think this is kind of like checking a flag, and if it's 1, then it will include this, and if it's not, then it won't. So I think we have not actually included it in the build, but the compare. Right, yes. Okay, so we need to change, we need to change the mpconfig port.mk to enable the new module. Or more specifically, we could just copy the one that should be like that here. That's in ports and then the specific. So expressif, that should overwrite a file, and it should basically just be like setting a 1 on something, or interesting. I think it should not really base it on audio bus IO because it doesn't rely on anything inside of there. I'm just going to change that to a 1, which I think will make it always on for expressif, and then we could go back, and if any boards overflow, we could turn it off for them. No rule to make target. Okay, do we miss something else here? Make sure, so it definitely has common HAL stuff, right? Expressive common HAL. Rule to make target. Build on a different screen. I copied all the necessary files over, but perhaps I missed some. Probably it's just add it to something else, or maybe the one that I used broke it, but I mean a bunch of those had ones. You need empty init C in that directory. I should have, because I copied the directory, so maybe it wasn't there. Okay, yeah, so it created it in both Expressive Raspberry Pi, copy that over to there, and then go again. Expressive, that's in Common HAL. What's up, Fede2? Nice to see you, my friend. Audio bus in, so that's this empty one here. And we would need the Raspberry Pi one as well, but I'm not building the Raspberry Pi port right now, so I'm gonna just skip it. Yeah, and in fact, I guess the error actually literally says the problem in plain English in this case, sort of more or less, which is effectively that this file didn't exist, and it doesn't need anything special in it. I'll go back and I'll fix the copyright years again, because I did this on the code that it generated the first time too. But it actually doesn't need anything, it just needs to exist. I guess because of the way the Python in double Double underscore init is like a Python name. I assume that's got something to do with why it needs to exist here. It is odd that this doesn't, there must be some other code somewhere that's automatically including these things in. I'm gonna say it's odd that this doesn't have to include these somehow as like being part of the module or whatever. All right, let's get ready to redo these things as well, since I'm kind of spread out across different browsers here. CircuitPython seems like a Docker container. CircuitPython, the repo, or you mean like when you run it on a device? I'm not sure how you mean, like a Docker container. There we go. I don't know. I think this is just superstitious. I'm not sure if I actually need to go up and back, but sometimes my sometimes different parts of my computer seem to be referencing old versions of files. Run it on a device, in a device. I gotcha. It does. I mean, I will say it does have like essentially a VM runs inside there, right? So the CircuitPython core has a small virtual machine that interprets the Python code and executes it. And it is kind of like its own, especially if you are doing the portions of CircuitPython that work the same as with CPython. It is kind of like its own sort of handheld contained sandbox for doing Python stuff inside of, or in this case, like on a physical thing, but it's encompassed in its own little world. So it is, I guess it is kind of containerish in that way. %. Oh, clear, like erase. I was gonna say, I don't know what clear text does. I was gonna click it, which is dangerous while it's running, but just means erase this thing, probably. Right, dun 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 dun, 100%, please reset. All right, there's the CircuitPython blinks. I still see no action on the NeoPixels, so no luck. Oh, it just took it a second to start up. Actually, it did go. And maybe disconnect here. Connect here. Nice. Yeah, totally. Go on, yeah. Okay, sweet. So that's working good. And we are moved in to our new module home there. I will update this code. Happen to notice that these are old. Comment, really, not the code. Okay. Let's take a stroll through this code, actually. I have not read it super in depth. I kind of got the gist of it and tested it a bunch and tweaked it a little bit to change out the different strips some, but I've not actually given it a thorough look over. So sample rate looks familiar from all the recorded examples. FFT size is specific to this one, of course, because it's the only one doing FFT. Has to be a power of 2. Okay, so how many recordings it's going to consider, essentially. 5512 samples equals 32 milliseconds. What does it do if we have more? Does it make it like lag behind or not work, run out of RAM? Check. Seems almost the same. Okay. Presume at some point we would either get to a number that's too big and makes it like weird, makes it try to consider too much at once, or and therefore it's just like maybe all of the lights are always on or mostly always on or something, or you might run out of RAM. I would not be surprised at some point either. List to set up the 3 strips. A list of tuples to define the ranges. One thing that might be interesting is to try with more stuff. So like maybe instead of NeoPixel strips, I mean, it's not what these are not the kind of pixels the Sparkle Motion is made for, but maybe we could do it on this and then have 13 different bands. I don't know if there's 13 bands that are distinct enough to matter. That could be kind of cool as well, though, as a different way to display more intricate data. Hertz to binary. Okay, so this will build a tuple of these values passed through this function. Build a tuple of tuples, a list of tuples, basically. Basically just converting all of these into binary form. Initialize the neopixels, that's part straightforward. This is the new API for I2SIn, which is more or less the exact same signature as the existing I2S out. So you give it the clock. Is it the same name though? We'll double check that actually, because is it? If it's not, we'll make it the same, I think. It should be. I think it must be. Bit clock, yeah, okay. Bit clock is the pin for clock, word select pin, data pin, and that one is just called data, yeah. Bit depth, and then mono, true or false, left justified. I'm not sure which Or which microphone is on the Sparkle Motion, actually. Does it say here? Doesn't. Would be in the, maybe in the datasheet. But that'll be tricky to... Oh, that one doesn't say either. We'd have to look in the parts, basically, build the material stuff. Okay. In any case, I do know that with this set to false, I can make recordings and they come out correctly. So I think false is correct for the one that's on the... It's that one. Oh, okay, this is the newer one, right? So I saw there was basically two... Oh, right, this... let me see here. Yeah, okay. Okay, yeah, I got... So I do have... and then there's this one. Yeah, okay. I have one of each, or I think actually I have two of this one. This one I think is older, I assume, because I saw that Micro Center had it stocked at one point, but I couldn't find one at my local one. Oh, that doesn't have a hole in it either. Okay. I guess the PDM one. Those are the ones maybe I'm used to seeing with the tiny hole in them. Very cool I2SIn. There's lots of projects that will benefit from I2S mics. Quick question, is there a connector similar to Sima that could be used for mics? I do not know of one. Let's look at the newer one. I think the pinout's basically the same. I don't know what LR left right clock. Oh, is the same as word select. Okay. I don't think there's a specific one, but yeah, I don't think there is a specific one. I mean, you could certainly find, like, you need... So this is not part of the data necessarily. This is selecting left and right channels. So you need basically 5, at a minimum, you need 5 wires. You need clock, you need data, you need word select, and then ground and power. This breakout also has a select for channel select, which it looks like would be just a digital I/O connection. Pull that high or low based on if you want mono or stereo, sounds like. Or maybe left versus right. Yeah, left versus right, not mono versus stereo, I think. So I'm sure there are 6-pin, like if you got a 5 or a 6-pin, I don't know if JST is the right word, but a little connector. I mean, more or less any shape little 6-pin connector you could theoretically use, I think. I certainly have not tried it, so theoretically could use it as strong of a statement as I will make about it, but I don't see any reason why you couldn't use, you know, something like these or those 2x3 ones that, yeah, like this one or these things even. Stemma uses the 4-pin. Okay, so yeah, if you find the ones that go 5 would be minimum, 6 would be good because that would even let you use like the channel select pin on this thing. And then I'm sure there are lots of 8s and stuff out there as well. You could just have a couple empty channels, wouldn't be the end of the world either. Not channels, but like wire lines. I'm going to keep stepping through this code a little bit. So it does have a raw buffer equal to the size of samples, 512 samples. I think that's probably integer for 32-bit ints. I thought we ran into an issue with 16-bit problem though. Maybe that was with the ULab, but that is a ULab array. What does that create actually? Well, that's array.array though, not ULab. I think those are, I'm gonna double check because I think actually sure on my whatever those are, the labels for the different format types. Oh. This should probably link to the actual, oh, does this one? Okay, I was gonna say this, one of these should link to the place. Unsigned int, 2 bytes, so 16 bits only, okay. Okay. I was gonna say, I think either ULab or the arrays, something could not do a 32-bit, it might have been this. I think it tried to do 32-bit size values here, which would match what's coming out of the I2S. Usually, from what I understand, they oftentimes output 32 bits of data, but like 24 bits of it are actually used. So having this be 32 would make sense, but it was not possible on CircuitPython, I think. Presumably one of these would be for like a unsigned long is for, or a float. And it tried that at first, but it was not working on CircuitPython. So now it's got 16 bits, and I think it just uses 2 entries in the array. Although it is interesting this is not ×2 or anything. Render strip takes the strip in, the color, and the level. The level being for the frequency that is applied to that strip. And it is just going to go through and turn on pixels based on the level, essentially. Loop over the pixels in the strip. The lit is equal to level times the number of pixels. So level must be a float, like 0.5, 0.1, whatever. Brighten the leading pixel and dim the tail. This we probably can't see very well, truthfully, because I have it set to only 10% anyway. Neopixels are fairly bright. So I don't, and I'm not like, it's not on display or anything. I just have it on my desk here. I don't want to blow out my retinas. Chaining the cell would be interesting. Yeah. And then in the loop, it does record into the raw buffer. Here we go. Okay, this is exactly what I was talking. So it even left a comment about this issue with the types here. So it was a different array, actually. Here, when it did from buffer, that's right. It was trying to do np.int, maybe int32 or whatever. Yeah, it was trying to do int32. But that doesn't exist in CircuitPython. So then it changed to 16, and then there I think it's using 2 slots of the array for each like sample that comes out of the I2SIn. Mike packs a 24-bit signed sample left justified in each 32-bit slot. So the top 16 bits of every slot are already signed int16 version of the audio. Perfect for analysis. Do that as int16 and take every other half word. So is it actually just ignoring the 8 bits that come after the first 16? Sounds like it might just be ignoring. But then this half words. So half words. Right. So that's just going to turn it into a numpy array. But it's going to use this size and it's going to come from this buffer. Signed is going to make a new array. Words 1, 2. I think this is every other. Skip a Han window to save cycles. Bands are wide enough that leakage is fine. It would be nice to go through and expand these variables. I don't know what RE or IM stands for. Could be words associated with FFT, I imagine. Which, other than a thing that processes audio, I don't really know any of the specifics. Take a look here. So this returns a tuple with the real and complex parts. So imaginary for complex. RE for real, IM for imaginary. Mags. Square root of real squared plus image squared. Feels like trig, sort of. Mags. I don't know what it would mean by mags. Magnitudes? Probably magnitudes. Oh, interesting. Maybe we could use that. What does that do? So that one takes an array and gives back an array. Welch. Huh. This one might be good for the larger matrix. What is I? Perform an inverse. Okay, then it's gonna go over the binaries, high and low end of the range. Energy is the mean of the magnitude. Low to high as a float. So one of the things this does also is update the like sort of noise gate type thing over time, the noise floor, I guess. So if you set it in a room that's quiet, then it will be more sensitive to sound. When sound does happen, quieter sound will cause more lights to come on than if it's in a loud environment. It will adjust to being in a loud environment. That's what I think the code here is kind of mostly responsible for. It's got this sort of like decaying, multiply it by 99.95%. Where the decay here is taking 99% of the peak each time. They should feel punchy, treble more responsive. Smoothed. Takes the level. Huh. Attack. Smoothed. Index equals. So essentially it's saying just 0.6 for the base and 0.5 for the others. But that is 1 minus that times itself. Just fixed a bunch of instances of these with due to rough rules where it could be, it's multiplying by itself, so it could be times equals right here, I think. Of course, in this case, it's also multiplying by more stuff. Yeah, I think it would still be the same, though. Or maybe not because of the parentheses. Maybe not because of the parentheses. I'm not sure about that part. Back times level. Soothed. Okay, so basically the values that come out of the FFT get used to calculate the level. The level gets smoothed out so that it's not just raw data from the microphone. It does a pass with this to presumably rein it in some. And then renders it using that level that gets calculated and put in the smoothed list. And then just do the whole thing again. Nice. Pretty straightforward. It would be interesting to see what the spectrogram one would do. That would do something kind of a visual. Okay, yeah. Assuming that that's the kind of chart that this function is gonna basically give you the ability to populate. Basically, you're getting a frequency, getting a mixed frequency, and this function is kind of being able to tell you which parts of it are appearing the most. Nice. Okay. Yeah, that would be cool. Okay. That is going to about do it. Let's see. Have the Adafruit window somewhere? I get a bunch of these ones. What's enough for a guitar tuner? Oh, that would be cool. Yeah, I hadn't thought about tuner. That would be really cool. That'd be a neat project. Yeah, I'm stoked to have the ability in CircuitPython to do this stuff. It's one of the remaining things where it's kind of like if somebody wants to do something based on that, kind of like we have this other one that's not as good, or else you kind of have to go to Arduino. So closing that gap and making it so that these sorts of projects can exist in CircuitPython. And I was worried a little bit about the overhead of running CircuitPython and having this actually stay sort of like real time and stuff, but it seems pretty good on this device. I'm stoked for sure. All right. That is going to do it for this morning's stream. As a reminder, JP will be up later this afternoon, 4 p.m. Eastern, 1 p.m. Pacific. You can get yourself great discounts on the chosen product of the week. As far as I know, Scott's planning to be around for Deep Dive on Friday. So that is at 5 p.m. Eastern on Friday. And then I believe I will be back over on my channel on Saturday morning, 10 a.m. Central, 11 a.m. Eastern. As long as I don't fill in for Deep Dive, then usually I do the Saturday streams. Thanks for working on this. Yeah, for sure. Thanks for helping out with the parody from the rest of the world of CircuitPython. Yeah, definitely. Thanks for hanging out in the chat, folks. I will see you all next time. Have a great day.